Hi, my name is Laura and I will be presenting Project 8, Adaptive immuno-seq Repository. This project was worked on as part of hackseqRNA Ultra COVID-19 Hackathon. This hackseq event happened between May 22nd to 24th, 2020 and it was hosted online. To learn more about hackseq or to become part of the volunteer organizing team, visit www.hackseq.com. The project we tackled was as part of Microsoft and Adaptive Biotechnologies initiative as they explore how the immune system responds to COVID-19. As part of the project, they gathered data from the Adaptive Immune Receptor Repertoire, also known as AIRR-seq data, from COVID-19 patients. The AIRR-seq data from the study is stored in Adaptive's publicly available immuno-seq repository. Our goal throughout the weekend was to convert Adaptive sample metadata file format into files that adhere to the AIR repertoire file format specification. I'd like to give a shout out to our team members, Brian Corey, Michael Crusoe, Nicole Nitze, Artem Kushner, Akif Manji, and myself. The workflow we followed is as follows. We found a study from ImmunoSeq to use as a test case. We then created a mapping from ImmunoSeq to AIR metadata, and we focused on a set of specific files. We then developed code to translate the ImmunoSeq metadata into AIR repertoire metadata. Once we had these three steps ready, we then developed a pipeline that connected the three, and then installed an iReceptor turnkey on Compute Canada's virtual machine that was provided to us during the hackathon. The next step in the pipeline is to load transformed ImmunoSeq data into an iReceptor turnkey. To provide a bit more detail, from Adaptive ImmunoSeq's website, the user has to create a username along with a password and provide a workspace ID. This information is provided to our pipeline to complete the download. Once this information is provided, the script then performs an SQL query and obtains a TSV format file. With that file, we then apply our mapping and tagging script to convert into a TSV that is AIR compliant. The TSV is once more processed and transformed into JSON format. This JSON file will be loaded into an iReceptor turnkey. What we did during the weekend is, using the common workflow language, we developed a pipeline that downloads the data, maps the selected fields, and then converts the resulting TSV into a JSON format. The mapping is as follows. We divide the mapping into two categories, direct mapping and tagging. Tagging can include either refinement of the fields or renaming. Direct mapping included fields that could be mapped on a one-to-one basis and only required renaming the field. For refinement, we extended Adaptive's ImmunoSeq data to include not only species but also an ID and a label, using their taxonomic IDs. We also refined age field to include a min, a max, a unit, as well as a label, and applied a similar logic to diseases. For future work, we hope to extend our work to transform the remaining fields in Adaptive study to make it into an AIR-compliant file format. Once we've completed that, our goal is to refine the JSON format resulting from our pipeline, and to complete the study, we will apply an existing mapping for data at the rearrangement level. Once we have a full data set at the rearrangement and repertoire levels, we can then upload an AIR-compliant JSON repertoire and rearrangement files into an iReceptor turnkey. This data will then become available for researchers to use as part of their research. I'd like to thank our hackseq organizers, as well as the sponsors and the community partners. Without you, this event would have not been possible.